Hello, and welcome to the University of Shed on prime numbers. A prime number is an integer, a whole number, which can be divided only by itself and 1. The first 5 prime numbers are thus 2, 3, 5, 7, and 11. Prime numbers differ from composite numbers, numbers which are not prime, which have other divisors. The composite number 12, for example, has 6 divisors: 1, 2, 3, 4, 6, and itself. There's no clear way to identify prime numbers and no pattern in how they appear. It's impossible, for example, to tell just by looking at the numbers 19,071 and 19,073 that the latter is a prime, but the former is not. It can be divided by 3, 13, and 163. As the writer Mark Haddon says, prime numbers are what is left when you've taken all the patterns away. Some people have also pointed to the mystical nature of prime numbers, noting that the number 666, the devil's number, or the number of the beast, is the sum of the squares of the first 7 primes, i.e. 2 squared plus 3 squared plus 5 squared plus 7 squared plus 11 squared plus 13 squared plus 17 squared. Prime numbers were first identified and studied by ancient Greek mathematicians, most notably Euclid in around 300 BCE. In his Elements, Euclid demonstrates that there are infinitely many prime numbers. 2,500 years later, supercomputers have identified more than 25 million trillion of them. Another Greek mathematician who worked on primes was Eratosthenes, who developed a so-called sieve, which, in the world before supercomputers, could be used to find all the prime numbers up to a certain value. This algorithm works as follows. Write a list of all the whole numbers from 2 until the maximum number in your list, for example, 25. Since the first number is 2, cross out every second number in the list, i.e. all the numbers which have 2 as a divisor. The next number is 3. Cross out every third number in this list after 3, which has not already been crossed out before. Repeat this process for subsequent numbers which are multiples. After doing this, you are then left with a list of prime numbers. For a long time, it was assumed that prime numbers were important only in pure mathematics, that is, the branch of mathematics focused on abstract concepts. For example, they are particularly important in the field of number theory. However, they are also useful in applied mathematics, which focuses on the real world, in particular public key cryptography, the system used for sending and receiving secure messages. There is also evidence that certain types of cicadas, a type of insect, emerge on 7, 13, and 17-year cycles. This minimizes the occasions when the different types of cicadas will be competing for the same food. The cicadas on the 13 and 17-year cycles will only emerge at the same time every 221 years. It also minimizes their risk to predators. For example, a cicada on a 12-year cycle would be at high risk from predators on a 1, 2, 3, 4, 6, or 12-year cycle. Finally, 2 other specific aspects of prime numbers should also be noted. The first is a type of prime number known as a Mersenne prime. These prime numbers take the form 2n-1 when n is a known prime. The primes are named after Marin Mersenne, a French monk who identified this type of prime back in the 17th century. As of 2020, 51 Mersenne primes are known. 3, 2 squared minus 1, and 31, 2 to the power of 5 minus 1, are the smallest. The largest, a number of nearly 25 million digits, is the result of the equation 2 to the power of 82,589,933 minus 1. The second aspect is the Goldbach conjecture, which states that every even integer greater than 2 can be expressed as the sum of 2 primes, For example, 8 is the sum of 3 and 5. Certain numbers are the sum of two sets of primes. For example, 14 is 3 and 11, or 7 and 7. This conjecture is widely assumed to be true, but is yet to be definitively proved.